Alright, the chain of motion. We will be connecting the relationships between displacement, velocity, acceleration, and unbalanced force. Let's begin with displacement. What is displacement? It tells us where something is relative to a starting point. It basically tells us about the position of the object. Let's say this is the starting point, and since displacement is a vector quantity, it depends upon both magnitude and direction. So we will assign a direction where we will consider the displacement to positive, and the opposite direction will be automatically considered negative. So in our example, we will be considering the right direction to be positive and the left direction to be negative. Now, how is displacement related with velocity? Displacement depends on velocity. How is that? Because velocity dictates how displacement changes with time. The definition that we have learned a long time ago, velocity is the rate of change of displacement. For 0 meter per second velocity, there is no change in displacement, as in the object doesn't move, the object doesn't change its position, the object is at rest, the object is stationary. We have so many different terms to mean the same type of motion. Then, if the velocity of the object is positive, what does that mean? It means the object changes its position to the positive direction, as in our example, it will move towards right. And if the object has a negative velocity, then the position changes to the left. And if the velocity is high, that means the displacement changes quickly, and in which direction the displacement will change will depend upon the direction of velocity. And if the velocity is low, then the displacement changes, but slowly. And again, in which direction the displacement will change will depend upon the direction of the velocity. Now, let's see the relationship between velocity and acceleration. Velocity depends on acceleration, not the other way around. Now, what is acceleration? Acceleration dictates how velocity changes with time. We know acceleration is the rate of change in velocity. Now, let's see how velocity depends on acceleration. If the velocity remains constant, acceleration dictates how velocity changes with time, as in acceleration is the rate of change in velocity. Now let's see how velocity depends on acceleration. If the acceleration is 0 meter per second square, this means there is no change in velocity, as in the velocity remains constant. This doesn't have to be zero velocity. It can be zero velocity or it can be any other value, but whatever value that is, it must remain constant. Does this sound familiar? Yes. This is the Newton's first law of motion, which says if an object is at rest, it stays at rest. If an object is in motion, it stays in that constant motion in a straight line until or unless there is an unbalanced force exerted on an object. Spoiler alert, acceleration depends upon unbalanced force. We will deal with that later. Now, let's continue. If acceleration is 0 meter per second square, as we mentioned, the velocity remains constant. And what if there is an acceleration? Then the velocity will change. But again, since velocity is a vector quantity, it depends upon both direction and magnitude. If acceleration and velocity act in the same direction, it causes the magnitude of velocity to increase. And if acceleration and velocity are in opposite directions, the magnitude of velocity decreases. But what happens to the direction? The direction of velocity stays the same. And if acceleration is perpendicular to velocity, then the direction of velocity changes, but the magnitude of velocity stays the same. This is what happens in circular motion. The acceleration in circular motion is called centripetal acceleration. We will deal with this in a later video. And if acceleration decreases, this doesn't mean velocity decreases. If acceleration decreases, this only affects the rate at which the velocity changes. So if acceleration decreases, the magnitude of velocity will change, but at a slower rate. And if acceleration increases, this doesn't mean velocity increases. The velocity will change. Of course, if there is an acceleration, there will be some change in velocity. But if acceleration increases, this doesn't necessarily mean that the velocity will increase. It means the velocity will change, but very quickly. So if velocity will increase or decrease, it depends on the relative directions between velocity and acceleration. This is what we have discussed earlier, that if acceleration and velocity are in the same direction, then velocity will increase no matter how small or how large the value of acceleration is. If the value of acceleration is large, then the velocity will change very quickly. And if the value of acceleration is low, then the velocity will change, but at a slower rate. Now, if it will increase or decrease, it depends upon the directions of acceleration and velocity. If acceleration and velocity stays in the same direction, velocity increases. If acceleration and velocity are acting in opposite directions, that causes the velocity to decrease. Now, as per the spoiler, acceleration depends upon the unbalanced force. When does an unbalanced force act on an object? When the forces acting on the object does not cancel each other out. So, if the forces acting on an object are not balanced, that means the unbalanced force is acting on an object. We also refer to unbalanced force as resultant force. So, if an object has 50 Newton force acting on it towards right and 20 Newton force acting on it towards left, then there is an unbalanced force acting on an object. We also refer to unbalanced force as resultant force. So, the resultant force acting on this object is 50 Newton minus 20 Newton, that is 30 Newtons. We will connect all these dependencies together in the most complete theory of all, the terminal velocity, and that will be in the next video.